Hey, you know, this is exercise 2G, which is on inequalities and is on page 111 of your textbook. So, hopefully you guys are feeling okay with the solving equations with the different variables like x and y, because if not, please do go back and revise those. They are the basis of what we will be studying over the next couple of weeks. So, inequalities, same as equations, except it's like an inequation, right? So inequalities are basically when I say, for example, x is anything that's less than or equal to or greater than or whatever. So you've heard these terms before. So inequalities can be illustrated, using a number line because the line represents an infinite number of points. So let's go ahead and look at this example over here. I've got x is more than 1, right? X is greater than 1. And if you forget, what these symbols are, it's over here, okay? Just remember that the crocodile eats the bigger one, right? So that's just the easy way to remember. Okay, so this one is greater than, x is greater than 1. So that means that x can be any number that's greater than 1. It could be 1, 2, 3, 4, 5, 6, blah, blah, blah. But it could also be 1.5, 1.25, 1.125, anything that's greater than 1. Now, you can also see that there's an open circle here, versus here, which has a closed circle. Now, the difference is an open circle is when it's greater than or less than, right? So you can see here, x is less than 1, but it does not include 1. X cannot be 1, right? In this case over here, you've got greater than or equal to and less than or equal to. So when x is greater than or equal to 1, it can still be 1. Whereas over here, there's no way it can be 1. It's impossible. Okay, so that's the idea. If I have if x is greater than 3, and I draw my number line, let's say that's 2, 3, 4. If x is greater than 3, I know that it can be anything more than 3, so any of that, but it cannot be 3, so I draw a big open circle. That's the idea, okay? So we talked about greater than, less than, but it's also possible for values to have bounds, both an upper and a lower bound. So in the example of this one over here, you can see that x can be any of these numbers, and because over here it's a closed dot, right, that means it can also be 3. So it can be 3, let's go ahead and actually check them. It could be 3, 2, 1, 0, -1, but it can't be -2. And it's not anything less than -2 because x here, as you can see over here, x is greater than -2, but not equal to or not less than. And over here, you can see that x is less than or equal to 3, but not over 3. Okay, so that's the general idea. So linear inequalities are solved similar to linear equations, so what we've done before. All the numbers that satisfy an inequality are called a solution set, but let's ignore that for now, right? Now, the golden rule is when multiplying or dividing by a negative number, so I'm reading this line over here, when multiplying or dividing by a negative number, reverse the inequality sign. So that's the golden rule, okay? That's the number one thing you need to remember. Let's go ahead and answer some of these questions so that we can understand where we are coming from. So, state the missing symbol to make each statement true. So just a reminder, this is less than, and this one is, as you can probably guess, greater than. Okay, so 3 is greater than 2, so I'm going to draw that. -1 is less than 4, so let's draw that. -7 is less than -3. Now don't get fooled, just because there's a 7 there doesn't mean it's greater, right? Imagine a number line. So let's say that's 0, that's -3, and -7 will be down there. If it's more to the left, it's lesser. If it's more to the right, it's greater, okay? Now, -3 is greater than -7, and -7 is less than -3, so I'm going to write the less than sign. 5 is greater than -5. Same thing, don't get fooled by that. Okay, match the inequalities A, B, C with the number lines A, B, C. So the first thing I'm going to note is that this one here has 2 bounds. Okay, you can tell it has to be between here and here, which is -3 and 0. If I look at this one over here, it's the only one with 2 dots, so one here, one there. And you can also see that this one has a a less than or equal to, which means it has to be a closed dot, and this one is a less than, so an open dot. Closed dot, open dot, perfect. So B is actually connected to C. Awesome. Now, it's between these two. For this one over here, x has to be less than 2. So which one of these graphs shows less than 2? This one here is actually showing x is more than -1, so that's wrong. And it has to be C, because here, open circle, and it's less than 2. Perfect. And that one makes this one correct. Okay. Now, find the solution set, so basically just means find the answer for each of the following inequalities. So x divided by 2 minus 5 is less than or equal to 3. I'm going to go ahead, and I see there's a -5, so plus 5 on both sides. So this should be relatively familiar to you guys. So I'm going to end up with x divided by 2 is less than or equal to, less than or equal to 3 plus 5, which gives me 8. Now it's times divided by 2, so I'm going to times by 2 on both sides, and then end up with is less than or equal to 16, and that's it. I'm done. Let's go ahead and do the next one. So I see that's 3 minus x over 9 is greater than or equal to 4. I'm going to go ahead and add, sorry about that. I'm going to go ahead and minus 3 on both sides, because it's plus 3, right? And end up with negative x over 9 is greater than or equal to 4 minus 3, which is 1. I'm going to times both sides by 9, because right now it's divided by 9, right? So times by 9, and I end up with negative x is greater than or equal to 9. Now here's where it gets tricky. I'm going to times by -1, or divide by -1, doesn't matter. Let's go divide. Divide by -1. Now if I'm dividing or multiplying or dividing by -1, I have to flip the sign. So I'm going to get x over here and -9 over there. I'm going to flip the sign, and I get x is less than or equal to -9. Okay. Last one. This one's easy. So it's divide by 5, so let's multiply for 5 on both sides. And I end up with 2x is less than or equal to 8 times 5, which is 40. Now it's times 2, so that's divided by 2. And I end up with x is less than or equal to 20. Alright, that's it. Hopefully that makes a bit of sense. Good luck.